All right, guys, I'm going to do a quick video with a couple of problems that we've been doing in class. So I want to stress a couple things with this. Variables and comprehension of what variables are given to you within the question and what you need to know based on constants. Okay, so first thing we'll do is we'll look at this problem right here. So let's read it. It says how much water vapor in grams is in a 2.5 liter container at STP. Okay, so first thing we need to figure out is what are they asking us? What are they giving us? What are they asking us? That's so important. And a lot of that comes down to knowing your SI units and knowing what those SI units are connected to. So water vapor, that's going to be my gas. And the key here is in grams. In grams, that's the key. So you should know grams is mass. Okay, so it's wanting mass. All right, so that's our end goal is mass. So where are we starting? That's what we need to look at now. So we're starting with 2.5 liter container. All right, so it's in a 2.5 liter container. So there's volume. So we know we're starting with volume. So if we have that 2.5 liters that we're starting at, and we're trying to get to mass, we're going volume to mass. All right, STP, that's the next thing. So our 2.5 liters is our volume. Now our STP is our next piece of information that we need. And what is connected to STP? So STP is going to be our 0 degrees Celsius and our 1 ATM as far as our pressure goes. So we need to start taking all these things and organizing them, because if we can organize them, then we'll have a better place to start and know where we're going. So for right now, what's given to us, we have water vapor. So we know water is H2O. That's our first thing. We know that we have our volume, which is going to be 2.5 liters. Oops. All right. And we know that we have STP. And STP can mean, as far as our temperature goes, our temperature that could give us a 0 degrees Celsius. And also for pressure, that gives us 1 ATM. Okay. So now we look at this and think, okay, if I have my PV equals nRT, that my ideal gas constant here, you look at that and think, okay, can I use that to solve for mass? Can I use that to solve for mass? Well, mass isn't in there. It's not in there. So you don't need that. You don't need that. So you're not needing the ideal gas constant here. So what's left? You can think, okay, well, I have my temperature and my pressure for my STP, but I also have my molar volume for my STP. Okay, so if I take that, my STP there, which is my 22.4 liters, all right, because that's the amount of space that 1 mole of a gas is going to take up at STP. I've got that conversion right there, all right, and I'm starting also with a volume of 2.5. All right, so now I need to think, okay, I can use that conversion to get to moles. And once I'm at moles, I can get to mass. So you've got to realize that you can't go straight from liters here straight to mass. You've got to get that intermittent with moles. So now that I know that that's the route I need to take, I also need to get the molar mass of my H2O. So this, and we'll go 15.999 for my oxygen, and go 1.008 for my hydrogen, and 18 grams, 18.0 grams. Okay, so again, where are we at right now? How did we get there? So step by step, we looked at the problem. So how much water vapor in grams is going to be in that 2.5 liter container at STP? So we know we have water, H2O. We got the molar mass for that. They want grams, they want mass. Okay, so I put my M equals. That's going to be where we're going with this. All right, we're starting there with our liters for my volume. We're at STP, which gives us temperature of 0 degrees Celsius, pressure of 1 atm, and also the molar volume conversion of 22.4 liters. So that's where we're at with this, okay? So now, in this case, since we are not using our PV equals nRT, we don't need our temperature and our pressure here. All right, all we're going to need now is going to need our starting spot at that 2.5 liters. All right, and then our conversion right here. So I'm going to go ahead and put my 2.5 liters right here, what I'm starting with. And I'm going to convert that to molar volume via my constant there. So I'm getting to moles, so moles is going to be my numerator here. Down here, my denominator, I'm putting my 22.4 liters. That allows me to cancel my liters. And now I can go ahead and divide that. So 2.5 divided by 22.4. All right, I'm gonna go 3 sig figs here. So 0.112. 0.112 moles there. Okay, so we're in a great spot because now we're at moles. We can go from moles to mass. We have our molar mass. So now 0.112 moles, all right? And we're going to moles to mass. Moles to mass is multiply. Anything to moles is divide. So we're multiplying here. So I'm putting my 1 mole down here. And I'm putting my molar mass of H2O, my water, up here at 18.0 grams. Go ahead and multiply that. Okay, so that's going to be 2.02. 2.02. And I've canceled my moles, and that's grams. That looks like a Q. 2.02 grams of H2O. And there's my answer. Okay. So, rundown one more time. You see a question giving you volume and wanting mass. You're not using PV equals nRT. There's no need for it. And yes, we wrote a couple things over here that we didn't need, like our temperature and pressure. We didn't need that, but that's okay. Forming habits of getting your variables on your left side, because most problems that we are using the PV equals nRT, and we would need our temperature and pressure. Getting everything gathered, organized on your left side right here, and then realizing, okay, what do I need to do? What's my pathway to getting my answer? And if you have volume to start, and it's wanting your mass, then you don't need PV equals nRT. All you need is your STP conversion factor here. And of course, STP is a big part of that. So it has to be at that STP because we are using that constant there. All right. So I'm going to give you problem, and you guys can work on this. And then if you knock this out, you can bring it to me and I'll check over it with you in class. Let's switch it up. Let's go. Let's say how much. Let's say you have 3.2 liters of CO2 in a container at STP. All right. How many grams of gas do All right. So there's your problem. You have 3.2 liters of CO2 in a container at STP. How many grams of gas do you have? All right, that's your question. Go ahead and do that on your own and bring it by with me in class, and I'll check it over for you if you need some extra help on these problems right here. I'm going to move on now to another question that's what we've also been working on in class. So part of your homework was going to be the 394, 21 through 25. So I'm going to look at number 24 in the book there with you guys, and we're going to work that out together here. So if you have not done number 24 on page 394 yet, do it first before you watch this section of the video. I want you to at least try it, and then once you try it and get an answer, then you can follow along with me and see where you went wrong. Learning is in large part through failure. So any kind of mistake you made, you can listen to the explanation as we're going through it, and that can help you in the long run. So 24 says calculate the volume that 4.5 kilograms of ethylene gas spelling that right. C2H4. It's going to be your C2H4 chemical formula there. Will occupy at STP. Will occupy at STP. Okay, let's analyze the question. What is it giving us? What is it asking for? So calculate the volume that 4.5 kilograms of ethylene gas, C2H4, will occupy at STP. Okay, so these are more of our regular problems that we've been working, or the majority of the problems that we have worked in class. So first thing, let's follow our routine. Let's write our formula. So that's going to be PV equals nRT. All right, let's write down what we have. We have 4.5 kilograms. That's our mass. So we'll go mass is equal to 4.5 kilograms. Then we have ethylene gas. So we have C2H4. All right. And we have STP. So let's go ahead and get the rest of our variables down here on our left side. So we have our pressure, volume, moles, our constant, and our temperature. Okay, so we can go ahead and get our molar mass of our C2H4. So we'll go ahead and grab that real quick. So we'll do it over here to the side. So our H4, 1.008 times 4, 4.03, 12.011, multiply that by 2. It's going to give us 24.0. All right, so we'll go, that's going to give us 28.0. Stick with 3 sig figs there. All right, so it'll be 28.0 grams as our molar mass. All right, so now we have our variables right here that we need to go ahead and handle. So again, look to what it's asking us, what we're actually going to be using this formula to solve. So it's calculate the volume. That's what it's asking us. So we know that this is going to be our variable right there that we're going to be solving. So now we have pressure left over, we have moles left over, we have our constant and our temperature. So this is where STP is so major. You've got to remember STP, this right here, that gives us our temperature and our pressure every time. So this is like more information that we need to pull out. So we'll just do that. So we've got our temperature right here, and that's going to be at 0 degrees Celsius, and our pressure at 1 atmospheric pressure there. So that's good to go. That is not, because we need to get that over to Kelvin. So going from Celsius to Kelvin, we just add 274.15. And when we do that, of course, that gives us 274.15 Kelvin. And we'll go ahead and box that in. That's ready to roll. All right. So we need two more things here. We need our constant and we need our moles. So we see our SI unit. Always look to your SI unit here for pressure, and that is ATM. And my ATM constant is going to be that 0.0821. All right. And of course, those constants are going to vary by if you have your kilopascals, mmHg, or your ATM there. So we're at ATM. There's my constant. So now I just have my moles. You need mass for moles. So we're in kilograms, so we need to go ahead and convert that over to grams because our molar mass is in grams. So 4.5 kilograms. And again, we're moving our decimal place over 3 times. So to see that, 4.5 there, 1, 2, 3, and then there's our decimal again. And we're filling these in with zeros. Okay, so that's going to give us the 4,500. So there's that. 4,500 grams. And we're going to mass. So, or excuse me, to moles. So mass here, mass, 2 moles. Anything to moles is divide. We have our molar mass right there. So I'm going to put my molar mass down here, 28.0 grams over 1 mole. So my grams are canceling and I have my mole left over. I'm going to go ahead and throw this in the calculator. 4,500 divided by 28. Okay, so 161. I'm going to round to 3 sig figs there. And so there's my molar value right there, and that's mole. All right, so 161, and that is good to go. So set everything up. I've got one variable to solve for now, which is my volume, so I can easily do that. We come back to my original equation, which is going to be my PV equals my nRT. And I'm going to derive this to isolate my variable I'm trying to solve for, which in this case is volume. So I have PV equals nRT. So to isolate that variable, you do the opposite sign of whatever's going on already there. So this is showing multiplication. So I divide, and I will divide that P, or pressure, off to isolate my V. What I do to one side, I must do to the other. So I come over here and I divide by P. That then gives me V equals nRT over P. And that is my new equation that I will use to solve and figure out what exactly my volume is for that 4.5K ethylene. So let's go ahead and throw it in there. My N is 161. So 161, I'm going to multiply that against my R, which is going to be 0.0821. And my temperature, which is going to be 274.15. And like I said before, with STP, if your pressure is on the bottom, it's not changing anything, but we'll put it in there. It's still 1 ATM, so we'll still throw it in there, but it's not going to change anything dividing by 1. So let's throw that in the calculator. 161 times 0.82. Okay. So that gives us our answer of 3,624. All right, so obviously that is not in 3 sig figs, so we are going to put it in 3 sig figs. I'll kind of bring it up a little bit here, bring it over. We got a little bit more room over here. All right, so 3 sig figs, if that's my 0.0 right there, if I just rounded it to 4 in that case, I need to bring that decimal place over. I need to put this in scientific notation for my 3 sig figs. So I'm going to bring it over to where I have 1 digit to the left. So I move it 3 times. So I can go ahead and put times 10 to the third because I've moved it 3 times. We need to determine whether that exponent is positive or negative. So you need to ask yourself, okay, I went from a larger number to a smaller number. When you go from a larger number to a smaller number, when you put it in scientific notation, then it's going to be that positive exponent. If I go from a smaller number and make it bigger by putting it into scientific notation, then it's your negative exponent, however many times you've moved the decimal. So that's times 10 to the third, and we're going 3 sig figs. That 4 does not round the 2, so that is 3.62 times 10 to the third, and we're dealing with liters here because we're talking about volume, so that's going to be liters. And then of course we'll put, for my ethylene gas, we'll put the formula as well. So that's liters of C2H4. And then right there is my answer. So again, the process. I know it got kind of convoluted at the end with a little room over there, running out of room. But the process, what's given to you, what are they asking you for? They're asking for volume, they're giving you mass. Okay. And they're telling you it's a STP. So you know, hey, I've got this right here is where I'm headed, that volume. So I write all of my stuff over here on the left as we did before. I started with what was given to me, my 4.5 kilograms, my chemical formula of C2H4, my ethylene. Then I saw that STP. I started pulling those variables out of that STP. I started pulling that temperature, that pressure. I made sure to convert that temperature from the Celsius over to my Kelvin. Then I looked at my SI units that came from STP, that ATM, and I knew that my variable or my constant was going to be that 0.0821. And then from there, I come up, I look at my mass, I say, all right, that's kilograms. I need to get that over to grams. I convert it over to grams, and then you're in a great spot because you can go from mass to moles. Okay, so I took that 4,500 grams, which was given to me there just in kilogram form. I took my molar mass of my ethylene, C2H4, and I used those two numbers. I went from my grams to moles by dividing by my molar mass, and I got my moles. Once I had my moles, I had everything I needed to throw it back into my formula of PV equals nRT, and that's what I did. Of course, I derived first. I had to move my variables around to isolate my variable there by just dividing my pressure on both sides. And then I was set up and I put those numbers in. I put all the numbers that I found or was given or is a constant due to STP. And that's it, guys. That's the process. You just go through that every time. What is it giving you? What is it asking for? And sometimes it's loaded, just like that STP has a couple things in there. So always stay organized. Put your variables over here and just follow that process. That's it. Okay. If you guys have any questions, let me know, and we'll go over whatever you need. You got this. It's a process. The more reps you get, the more comfortable you're going to get with this stuff. But I have full faith you guys can get this. And if you have any questions on this, or if you've done the previous problem I left for you, you can come see me in class, and we'll go over it together.